So for this video, we are going to look at changing the period. This is something inside of trigonometry when we have a coefficient in front of the variable x. Some textbooks use the Greek letter omega, and for this video I will be using, like the book I'm using, the capital letter B. The capital letter B is going to change the way the period duration is. Normally for sine and cosine functions, the ones we're going to look at today, these periodic functions will repeat every 2 pi. But if we put a number in front of x, it's going to make it longer or shorter than 2 pi. So the first thing we want to do is we want to take a look at the period formula as defined by the book, plus something that I use when the period can be a little tricky. Because measuring out the period, if we took a look at what we did before in previous videos, and I highly recommend you go back and watch those. The previous videos, one period of sine was finished at 2 pi, and the next period was finished at 4 pi. But that's not going to happen right now because we are going to change the speed of our wave or periodic function. By changing the speed, imagine a note being made faster or slower. Think of like taking a record and playing it on a different speed than what it was originally meant for. Alvin and the Chipmunks, back in the old days, they actually recorded somebody's voice at a normal speed and then sped it up. And that probably took a lot of time to practice how slow you'd have to sing to speed that up, on tape, which is done a lot easier now with digital effects. Someone can talk in a normal voice and then they can just pitch correct that, which we're going to talk about later. But this is actually just changing from slow to a much faster part. So I'm going to erase these because we're not going to go in a normal 2 period to 4 pi setting, because by changing the number in front of x, we're going to change how fast or slow this periodic wave is going to go. Now here's the periodic formula defined by the book. 2 pi for sine and cosine is our normal period length. But then, if we divide by the absolute value of b, this will give us our new period length. Now the reason why there's an absolute value there is because this could be positive or negative. You're going to find that almost all of your problems are going to be positive, and if they were ever negative, which means they went in a clockwise formation instead of a counterclockwise formation, we would probably take care of the negative before doing the problem by using one of our even-odd properties. So what we have now is a formula we can use to figure out our period. Now, one method that I like to use, because sometimes finding the period will then make things kind of difficult, especially if it's not divisible by 4, sometimes I like to do the gap method, because pi over 2 has been our gap for every one of our graphs so far, and that's because we go from here to 2 pi and here to 4 pi. All of these gaps are pi over 2 in length. Now, I can take that pi over 2 and divide by b, or absolute value of b, but I like to just go 1 over b here, and that will give me the new gap length, and then I can count by that gap measurement. I'm going to show you how to do each graph using the period formula defined by the book and also the gap method, and then you can choose which one you want to do for the rest of the chapter. The gap method isn't as common as the period formula, but the gap method I think has its advantages. So let's take a look at the period formula and the gap formula for this sine these sine functions. So what we have here is the b of 2, and if I was to graph this sine of 2x, I'm going to have to find its new period. So I'm going to take 2 pi, its normal period, and divide by the absolute value of b, and 2 divided by 2 is pi. And so the period would be pi, because this would be our medium high, medium low, medium of our sine wave. Now, here's something cool that you might have noticed, that this is now sine of 2x. But it looks like this is moving just as, I mean, if you look at all my sine waves that we've done, you can see all the sine waves have the same, kind of curvature and medium, high, medium, low, medium. But you'll notice that instead of this landing at 2 pi, it's now landing at pi. So what this 2 has done is it's doubled the speed. So instead of this finishing its first period by 2 pi, it's finishing its first period by just pi. And then this would then be 2 pi. So we actually get 2 periods done in 2 periods done by 2 pi. It should be a little curvy there. We used to have just 1 period done by 2 pi. So this 2 has made this go twice as fast. Now, what you'd then need to do is then you would need to divide the pi by 4 and mark each of your other x marks by that. So this is where I want to show maybe the strength of the gap method. The gaps always start off with pi over 2 in this formation for sine and cosine. So what I'm going to do is multiply by 1 over b, and 1 over b would be 1 over 2, and so multiply top times top, which is pi, and bottom times bottom, which is 4. So this tick mark is pi over 4. Now I can just move up by counting by fourths. 1/4, 2/4 is 1/2, 3/4, 4/4 is just pi, 5/4. Notice I'm doing all of my fractions without the pi on it. Don't forget to leave your pi off. So there's 5/4, then 6/4. 6/4 would be 3 pi over 2 simplified. Gotta simplify. 7/4. All right, and there we go. 8/4 makes 2 pi. So that's how we can do the period formula or the gap method to figure this out. Now you can do one or the other. You can just stick with the period formula and divide pi by 4 and get all the same answers. But I'm going to show you again both techniques just to see which one you're going to pick. Okay, so we're on to the next problem here. So again, my sine wave is medium, high, medium, low, medium. And again, some people might argue that, Anderson, aren't you just making your students graph the same sine and cosine waves for every picture? And I'm saying, yeah, I mean, you have to think harder to make sure that your period and your gaps and everything is right, your maximums and minimums. We're still going from 1 to -1 on my y-axis. You have to think about these things more in depth rather than trying to draw it to scale. And if you were to draw it to scale, you might as well just have technology do it. So let's do the gap method. So here we have 2 pi divided by 1/2. Now, dividing by a fraction, please don't cry, skip, flip, and multiply. So we skip the numerator, so 2 pi. We flip the denominator, 2 over 1, and then we multiply. Top times top, bottom times bottom. And there's a 1 down here. So 1 times 1 is 1. We wouldn't put that on our final answer. So the period is now 4 pi. Now you could divide that by 4 and get all the rest of your tick marks, but instead of doing this method, you could have done the gap method, which is you take your pi over 2, which is the gap for sine and cosine, and then multiply it by 1 over 1/2. Now 1 over 1/2, again, we're going to rewrite this as pi over 2, and instead of 1 divided by 1/2, dividing fractions, please don't cry, skip, flip, and multiply, we skip the 1, we flip the 2 over 1 over 2 is 2 over 1, and then we multiply. So what we have is 1 times pi times 2, which is 2 pi, times 2 times 1, which is 2, which simplifies to pi. So my gap is now pi. So this would be then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and then finally 8 pi. Now some of you might have think, but geez, Anderson, way back in the gap method, I know how to divide 4 pi by 4. I've taken college algebra. And I get it. But sometimes, you start with the gap method and it just kind of fits in the same way. So that is how we do the gap method. And these are 2 examples of sine functions. And now we're going to move on to the cosine functions. So for the cosine functions, you're going to find that these are similar to the sine functions. Now, I should have highlighted a little bit in the last problem, and you can take a look at your worksheet, that we had the sine of 1/2. You'll note that what we did is we created basically this 1/2 to be going half as fast. So you'll see that we completed one full period in 4 pi instead of completing it in 2 pi. So the wave, in fact, got stretched longer, or the note got lower, because it's actually waving in much a longer way. So let's talk about cosine of 3x. Okay, so what this means is that we have the cosine formula of high, medium, low, medium, high, medium, low, medium, high. So here's our cosine wave, and the cosine wave is going to look the same in each of these pictures, and what we're going to do is adjust our period. Normally this would be a 2 pi here, but it's no longer going to be a 2 pi. What we're going to do is we're going to take our 2 pi, divide it by our absolute value of b. In this case, it's going to be 3. So this is 2 pi over 3. Okay, so this becomes 2 pi over 3. All right, now divide that by 4. See? Since our fraction muscle in our brain is a little weak, we're going to struggle a little bit taking 2/3 and divide it by 4. And this is where the gap method, I think, really comes in handy. So if I switch to the gap method, because normally this first dot right here, right after the origin, would be the gap of pi over 2 along my x-axis. Well, we're going to multiply that by 1 over b. In this case, b is 3. So my gap's going to be pi over 6. So this is pi over 6. So this then would be 2 pi over 6, which is reducible to 1/3. Now, your fraction muscle has to get strong as you do these problems. And I would please, instead of trying to do a fraction, convert to a decimal, then reduce the fraction on the calculator, try to do the fractions in your head. You have the capabilities. It just takes some time to warm it up. So there's a 1/6, there's 2/6. 3/6 would be pi over 2. 4/6 would be 2/3, which is great because we know we got the right answer then. 5/6, 6/6 is going to be pi, and then 7/6 is here. Again, I'm putting my pi in my numerator. And then we have 8/6, which is 4 pi over 3. Which kind of makes sense. If this was 0 pi over 3 and this first period is 2 pi over 3, then the second period would be 4 pi over 3. So 2/3 plus 2/3. Wow, so that was a lot tougher, wasn't it, when you had a denominator that wasn't easily divisible by 4? Well, let's check out this. Let's check out this slowing down of the period, because this still sped things up quite a bit. We're finishing this 2 periods right after we get done with pi at 4 pi over 3. So now we're going to slow this down quite a bit. And of course, this is going to be 1/3 of the speed. So this 1/3 of the speed means that it's going to be even slower than the sine problem up above, because that was at half speed. 1/3 of the speed is much slower. So we're going to go 2 pi divided by the absolute value of 1/3. Well, dividing fractions, please don't cry, skip, flip, and multiply. So 2 pi times 3 is 6 pi. So now this is going to be 6 pi, which is going to make this 12 pi. So we're going to go our high, medium, low, medium, high, and then get our nice little period 1, high, medium, low, medium, high. And here's our second one. There we go. So here we have our 2 periods. All right, so it's time for our wonderful fraction here. Let's get our gap, pi over 2, and multiply it by this 1 divided by 1/3. Again, dividing this fraction, please don't cry. Let me write my pi over 2 first. We're going to skip the 1, then flip the 3 over 1, and then multiply all these across. Pi times 1 times 3 is 3 pi. And then 2 times 1 times 1 is 2. So this is going to be a little trickier to count, but trust me on this one, it's going to work out fine. 3 pi over 2. Now we're going to go another 3 pi over 2. So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. And 6 pi over 2 reduces to 3 pi. 6 pi over 2 plus another 3 pi over 2 makes 9 pi over 2, which then, if we add another 3, makes 12 pi over 2, which is 6 pi. 12 pi over 2 plus another 3 is 15 pi over 2. 15 plus another 3 would be 18 pi over 2, which is 9 pi. And then 18 pi over 2 plus another 3 is 21 pi over 2. And then another 3 onto 21 pi over 2 is 24 pi over 2, which is 12 pi. It checks out. We did it. We did it right. And again, your fraction muscle inside your brain, your ability to do fractions like I did in my head, probably won't be as fast. But trust me, if you build up that fraction muscle, you will make fewer mistakes, and you'll be pretty happy about this. Now we're going to do 2 more examples of changing the period, and yeah, it's going to be pretty cool how this works out, because you're going to see something really cool happen to the x-axis in these next 2 problems. So for these final 2 examples here, we have our letter b, or our omega, or our period modifier, to be actually a radian instead of a whole number. So instead of 2 or 3 making the wave go faster, or a fraction, like a 1/2 or 1/3, making the wave go slower, something cool happens when we have a radian in here, and I'm not going to kind of give it away right now. I just want you to, let's investigate the period formula. So 2 pi divided by the absolute value of pi over 4. So 2 pi, and then what we're going to do is we're going to skip and flip and then multiply. But check it out. The numerator and denominator have a pi in it, so those simplify. You would use the word cancel, but it's simplify. It would simplify to 1, and then that would make the period now an 8. So 8, that is your period. That would make this 16, and then you would divide the 8 by 4 and get all of your units here. Holy smokes, that's easy. Now, in case you use the gap method, instead of going to the period formula first, the gap method would be taking your pi over 2 and multiplying it by 1 over pi over 4. Now again, I'm going to kind of shortcut one step here. 1 over anything is the reciprocal, so that means I can just take this 1 over pi over 4 and make it into 4 over pi. That's taking the reciprocal of it. So 1 dividing by a fraction is just the reciprocal. And you saw that in multiple examples now, so you can probably see why this is the case. These simplify to 1. 4 times 4 over 2 is the same thing as 2, and that's what you get when you get 8 divided by 4 is 2, 4, 6, 8, 10, 12, 14, and 16. So when we draw our wave, cosine is high, medium, low, medium, high. You can see that now we're going in units of 2. So we've converted the units into whole numbers, which is really nice. Now, it doesn't always have to be a whole number. It can be a decimal. It can be any kind of integer. But this kind of worked out nicely. It's a good example. So let's do our last problem of the video here. You may want to pause the video. Why don't you pause it and try it yourself and see if you can get it right, and then try to fill in all of the x values. And I don't care which method you use. Start with the gap method, or start with the period formula. It doesn't matter. So hopefully you've tried this out. So let's go with 2 pi, which is the period of our sine and cosine, and divide it by pi over 3. Well, again, skip, flip, multiply. So we're skipping the 2 pi. We're flipping the 3 over pi. And what we get here is these simplify. So now we have 6, and this will be 12. So just divide your 6 by 4, and you'll be in business. We're going to use fractions, of course, so let's go with the gap method. So we have our pi over 2, and then we have 1 divided by pi over 3. We'll do a little quick manipulation of this problem to be pi divided by 2 times 3 over pi. The pi's simplify, so our gap is 3/2, or 1.5. But again, stay away from our decimals here. This gap is going to be 3/2, and 3 halves plus another 3 halves is 6 halves, and 6 halves is 3. And then 6 halves plus another 3 halves is 9 halves. 9 plus halves plus another 3 halves is 12 halves, which is 6. 12 halves plus another 3 halves is 15 halves. 15 halves plus another 3 halves is 8 halves, which is 9. And then 18 halves plus another 3 halves is 21 halves. And 21 halves plus another 3 halves is 24 halves, which is 12. So you can see the 3, 6, 9, 12, and then the equal spacing between them all. And don't forget the sine wave. We've been so focused on the x-axis. Medium, high, medium, low, medium. Here's your sine wave. Perfect. And then medium, high, medium, low, medium. Here's your second sine wave. All right, that was some good exercise, getting you ready for period changing, shifting, pitch shifting in periodic functions of sine and cosine. In the next video, we're going to do some vertical shifting and throw everything else back in the mix. So we're going to have amplitude adjustments and period adjustments and vertical shifting in the next video. Just continuously adding on to what we've known before in periodic functions of sine and cosine.